Good morning, everyone. Welcome at the Upgrading the Grading. Let's talk about progress made and plans forward virtual panel session. Presented by the IDC Drilling Contractor magazine, supported by IDC and IADD, and created by the work of more than 100 volunteers over the past year. My name is Robert van Kulenberg, and I will be kicking off this virtual panel session today. We have a packed 2 hours, so I hope your coffee cup is full because we will be blazing through a lot of work being done. This event has created for you, so please ask questions. We need your input today. There's a question and answer box open. You can find it amongst your controls in the Zoom meeting. We will try to answer as many as we can live, and otherwise we will provide answers as soon as possible. There's also a dedicated email address, bitsdrillgrade@idc.org. If you want to contact the DrillBits drill grading team with any questions, volunteering offers, training materials, and whatnot, it's IDC, so it's impartial and not affiliated with any company. If you send an email to that email address, it will land with the team members as appropriate. So today's agenda, let me see if we can move forward a little bit here. There we are. Today's agenda is 10 minutes for a broad overview of the project. That's this overview, followed by 20-minute sessions of the first subgroups. We have a short break of 10 minutes then, after which we'll resume with another 2 sessions of 20 minutes each. Finally, Paul Pastusek will offer some closing remarks. And before we really start, let's get the antitrust guidelines out of the way. It's appropriate for IDC and its members to engage in a variety of beneficial activities, including development of proposed standards and collection of industry statistical data. It is prudent for members to exercise caution, however, and refrain from discussions or joint action in connection with the following topics: current or future practices, price adjustments or discounts, profit levels sought or attained, dividing or allocating customers, markets, or territories, any refusal to deal with or boycott a customer, potential customer, supplier, or potential supplier, activities that would lessen the abilities of others to compete or potentially compete with IDC members, restrictions or limits on the availability of services, any limits on sales or services or use of equipment. Any action recommended by IDC to its members is to be voluntary, not mandatory. Each producer, drilling contractor, or associate member must make its own individual marketplace decision whether to follow any IDC recommendation. If you're interested in the full text and context, I encourage you to visit the website location at the bottom of the slide. So with that out of the way, once upon a time, performance was good, with drill bits lasting a whopping about 721 feet per run, and grading was easy. Now performance is around 5 times better. However, grading became simpler. Well, not really, I guess. So about 2 years ago, IDC, with the enthusiastic support of Paul Pastusek, I'm not sure if it was the other way around, recognized that the existing bit drill grading classification needed to get a major upgrade to prepare for 2022 and beyond. The identified limitations of the current IDC bit drill grading revolve around 5 core areas. It was heavily focused on justification of pooling and not on the root causes. A heavy reliance on human expertise, not including common bottom hole elements, no framework for metadata inclusion, and no or limited support for automated drilling systems. In short, the current system just didn't cut it in today's environment. So in 2021, the IDC bit drill grading upgrade project set out with 4 major objectives to improve on the 5 identified limitations. Support root cause analysis, and by virtue of this, continuous improvement. Eliminate subjectivity, or the human element in most cases. Support both human and automated systems, and fully embrace the digital world. And as of note, the improved code set will be backwards compatible with the existing grading system, although it will then lose a lot of its detailed analysis functionality there. So where are we in the timeline? The existing standards were created in 1987 and then revised in 1992. For 29 years, nothing really changed until January 2021, when this project kicked off with the first virtual panel meeting. And on August 2021, an intermediate update was presented. The plan is to put the new standards out for trials mid-2022, and by the end of this year, have a final consolidated document out for comments. And you might ask, oh, it is all 3 virtual meetings. Well, no, You will see that in the next hour and a half. On the background, there have been more than 100 sessions on the sub-teams, which I will present later on. And a major part of the project was and still is education. I think I can speak for all volunteers that everyone learned a lot along the way. And you will notice this as well in all the presentations of the teams later on, that really high quality work has been delivered. So the work has been divided into 4 groups: drill bits, bottom hole assemblies, case studies, data storage, and retrieval. The drill bits team was led by Dustin Lyles, Tom Roberts, and Chris Probst. The bottom hole assembly team was led by Paul Neal, Roland Ilerhaus, and Jim Oberkirchen. Case studies team was led by Willie Watson, Fred Dupree, Isabel Witt-During, Rafet Abbas, and Ty Cunningham. The data storage and retrieval effort was led by David Shackleton, Kyle Grant, James Ney, Nathan Zanero, Daryl Fett, Tartan Collier, and Jonathan Sharp. And deliberately, the leadership team bar has been placed underneath the teams. The teams is where the work is actually being done. The leadership team just provides the proper foundations and ensures that there are minimal overlaps in the work. The leadership team comprises of Paul Pastusek, Dustin Deschel, Robert McMillan, and myself, Robert van Cudenberg. Do we have industry support? I might be inclined to say we do. This is one of the truly collaborative efforts in the industry today. So deliverables of the project can be placed into 3 buckets: outreach and education, codification, and digital guidelines. This year, we will see a lot of effort focused on the outreach and education. Writing a standard is one thing, but actually get it generally accepted by the industry takes a lot of time. Diving a little bit more into the outreach, you can see we have been quite busy, and I can all invite to the IADC SPE International Drilling Conference and Exhibition, where this group is presenting 3 papers, and more are planned this year. There are also preliminary thoughts on widening the outreach to universities and colleges as well. Have we achieved a lot in the last 12 months? Yes. Is there a lot of still work ahead? Yes. There are 2 major efforts this year that need to be finalized: the combination of the work of all 4 teams into one overall IDC guideline, which will be a major effort. In parallel, the proposed new bit dual grading system must be tested to see if it really covers all areas. For this, we need the industry help by actually using this grading system in normal workflows. So I'd like to ask the audience to use the provided email address, thebitsdualgrade@idc.org, and send us just a short sentence: yes, I would like to support the trials. Please include me in the trial group. It takes about 2 minutes of work and would help us out enormously later on. With that, on to the drill bit group.
Thanks, Robert. Well, good morning, everybody. Thank you for attending today. Our team consists of Dustin Lyles, who will be talking a little bit later on our key achievements, and also Chris Probst and myself, with the support of a large group of subject matter experts. The outline today, plan to review our objectives along with the charter statements provided, followed by progress to date. I'll introduce the advanced process map. This is really used to capture how we dual grade today, via the rig, via what we call the shop grade, the more forensic analysis done by individual drill bit companies, as well as the automation, the machine learning techniques that are available today. This leads very well into the grading every cutter, which is we're currently working on training examples, so we'll move on to that, and then Dustin will talk about the key accomplishments as well as any additional considerations related to reasons pulled, that type of thing, and then we'll finish on the next steps, what we're planning to work on next. So our objective was to really rewrite the IDC dual grading system, better understand and support the workflow for focused on continuous improvement and root cause analysis. This system of the grading system will focus on a qualitative classification scheme, focus on PDC cutters, drill bits, and tools with cutting elements, with a secondary priority on quantitative analysis. One thing to note here, The areas that you see highlighted are areas that are pretty much complete. We have touched on the other areas, of course, but more work is required in that area. Our focus was really a lot on PDC drill bits. When we think about the IDC system today, it's been almost 3 decades since we've done a major rewrite of the system. And back, of course, all those years ago, the market was very different to what it is today. Roller cones were king of performance drilling, probably more like 80%, and PDC drill bits were in their infancy. And over this time, the tables have turned, and PDC drill bits are now leading at least 80% of the market. So our focus, quite rightly, was on the PDC drill bits. However, we want to make it compatible with roller cones, reamers, and under reamers, hybrids, etc. So we believe that the existing system of grades works very well for the roller cones, but there are a lot of new upgrades in technology to bring PDC good forensic analysis. So again, just to highlight, we've defined a set of standards. We've focused on the cutter classification codes and documenting those codes. And I'm not going to go through all of these points here, but you can see some of the areas that were laid out from the charter statement. So this really is just a quick overview of where we are right now. As I say, we had a large group of subject matter experts that were kicked off at the beginning of 2021. We've had some around about 20 meetings, 17 with the SMEs, and at least 3 with the leadership group, Paul, Dustin, Robert, and Robin. We've had really good attendance at these meetings, typically about 30 to 50 on each of these meetings. These were run every 2 weeks, early morning. And as you could expect with so many subject matter experts, that there are some strong feelings or strong opinions, I should say, one way or another. So we made extensive use of polling. This helped us to get the general opinion direction that we needed to go. And an example here I'd just like to share with you. At one point, there was a lot of talk about forensics, and sometimes it's not as easy as we all believe it will be. A lot of this, of course, is to find the root cause and figure out what's going on. And in this situation, we would do a poll and ask the group, do they believe this is mechanical impact? Is it thermal, or is it a combination of both? And quite rightly, the result here shown by the orange bar, majority said that this was thermal. Another example here, same questions and looking at the grades, what do they believe they see? And in this situation, quite rightly again, most of the group felt that this was more of a mechanical impact type damage. And then this one really was put in there as a bit of a fun example, really, because the same questions were asked, and we got a mixture. Typically, people were going for a combination because they could see some kind of breakage down the side here. But in actual fact, this was a thermal abrasion test done in the laboratory, and no vibration, no impact. And here the residual stress caused the cutter to fail. So the point of this type of polling really was just to really show that it's very important to get to the root cause. A lot of energy and effort needs to be put into that ahead of time to really understand what we're dealing with. And this will allow us to make the best decisions moving forward, what we do next. So in terms of where we are right now, we've created a training document. This has been drafted with, and I'd like to again really thank the subject matter experts that we've had. It's been a group effort for sure, and I'll let Dustin talk a little bit more about that. We have about 42 pages of content so far, and really, like I say, right now we're working on those training examples so that we can utilize some of the new classification codes that have been created and take it to the next level. So this is our advanced dull grading process map, and we had this early on, and basically it's had some refinements, but if I just walk us through this, if we start with the dull bit on the far left, really there, in terms of the dull grading, there are three processes that are currently taking place. We have the rig grade, which we're all familiar with, and so this is really a visual evaluation. It's done, it's really the roughest type of grade that we currently have with the IADC. Then we have automated, and this is really systems that are being developed to machine learn using cameras, using scanners, even iPhone apps are being developed where they can really look at and photograph the drill bit, create a 3D image of that drill bit, and understand the grades. So these systems are being developed. There's been a lot of work in that area in the last couple of years, and a lot of progress. So I would say in the next couple of years, you're going to hear a lot more of these, about these. They're developing fast and very close. There's a lot of refinements necessary, but they're very close. And then finally, there's the shot grade. And again, this is really what we do today in terms of more advanced forensic analysis. And this is where we do the typical cutter by cutter, individual cutter data analysis. So both the machine learning and the shot grade do the cutter by cutter. So this will feed through to an IADC shot grade. We're looking to have split the grade in terms of a rig grade, which is still similar to what we do today in terms of the grading at the rig. And then we're going to have the more accurate forensic shot grade. So the importance of the two, really just to finish, is that the rig grade, of course, provides real-time decision making and is still extremely important, but both will come together in terms of advanced forensics. Like I said, we're working on these training examples right now. Really, if we just walk through the three steps, the idea, of course, is to grade every cutter that we're dealing with for greater accuracy. And we really start by defining the process of how we grade the single cutter. And again, Dustin will be talking about some of the key achievements and the changes that we've made. Then we move on to grading this into the chart that you see, the second stage on the right here. Really, we're looking at the percentage of diamond table that's been lost in this column here. Then we have the new diamond classification codes that are being provided. This is whether it's a worn cutter, damaged by spalling, etc. And then we have new classification codes for substrate damage. This can be related to corrosion, erosion, etc. And then we have the IADC location as a relating to the existing system. Then from this, we can summarize the results into the cutter damage severity, as you see here on the third section below. Again, it'll give us the overview, the zone, if you like, the cone, nose, shoulder, and gauge. And then, whether we're looking at the primary cutting damage category or the secondary damage classification. So that's just a quick overview of how the examples will look, and we're looking for, again, for volunteers to help with this. Please step forward with what Robert showed earlier. But that's it from me. What I'd like to do now is hand over to Dustin Lyles, who's going to talk about some of our key accomplishments to date.
Perfect. Thanks so much, Tom, and good morning to everybody. So we'll keep rolling here. I'd like to hit on some of the key accomplishments to date for the drill bit group, as Tom had mentioned. One of our first tasks was to completely overhaul the damage classifications or categories. So the old system we all know of was updated in 1987 to incorporate fixed cutter bits. It listed 26 dull characteristics, but we know those were very general, and the majority of them were actually more focused on roller cone bits and did not do a very good job of giving us granularity or detail on the types of damage that is predominantly experienced on PDC diamond table. So our newly proposed damage categories are focused solely on PDC damage. This is not a comprehensive list that we're showing here, but it does highlight some of the more noteworthy and new categories. You'll also note the more detailed shop grade categories in red. So as Tom had mentioned, we do have the rig grade and the shop grade. And so the idea here, at least initially, and this is all subject to change as we do our field trials, but would be that we don't have as comprehensive of a list at the rig level to not overwhelm them. But then as we get into the shop grade, we have a more comprehensive list that gives a high level of detail and a lot of options for the automated machine vision based systems, as well as when we have engineers evaluating dull bits at their local facilities. So like I said, there in red would be the shop grade. So a few of those that I think are noteworthy. One would be that chamfer damage there on the top left. This, we did debate about this, honestly, because while it is wear, a lot of times it's missed, it's not captured, and it's not documented. But that wear initiation is extremely important to understanding drill bit performance and as part of our feedback loop for evaluating and optimizing drill bits as well as the entire drilling system. Another one I think that's worth noting would be there on the right. You see that we, instead of just having the general brake category as was in the previous system, we now have segmented that into axial brakes and tangential brakes. And obviously the key importance there is that we can better understand and start to capture what the root cause analysis was. So if we know what type of brake it was, we can glean from that the type of loading that would have occurred to cause that type of failure mechanism. A couple others that are interesting there, face cracks, obviously, and then the beach marks, which kind of have a very specific shape to the type of spalling that you're seeing there. And again, that's indicative of the type of loading that would be seen. So these are some of the more noteworthy damage classifications, but like I said, not the exhaustive list, and we're continuing to develop and will continue to probably likely iterate and improve upon these and add additional categories as we get into the field trial stage. Thank you, Tom. And so moving on, another key accomplishment here would be looking at the wear severity measurement system, as well as we've included a category specifically to evaluate the substrates on the PDC cutters. So previously in the old system, the only classification that even talked about substrates would be heat checking. That was general and more related to roller cones. As you can see here on the right, we have now broken this up. We will have that specific category to talk about substrate damage, what type of wear and tear is observed on the substrate. This is really critical, especially if we look like at the example there in the center that's notated by the CRS, that is corroded substrate. So you see all that pitting, and obviously we know that that is a sign of, either a lot of times H2S and or potentially caustic mud. And when that occurs on a drill bit, it's obviously very critical, not just for the drill bit providers, but for the operators to know that there either one is H2S present or two, the mud is caustic, and it lends itself into pushing that person or that organization to looking at other BHA components, because it's likely that it's not only the drill bit that experienced that type of corrosive damage. And then we also included the corroded substrate, because a lot of times we do see that goes hand in hand, especially a lot of West Texas applications today. And then leaving in the heat check substrate, as well as a category for no damage to substrate, which is also important. We want to know when there's damage, we want to know when there's not. Moving down, and if I could draw your attention to the image there on the bottom left, we spent quite a bit of time, and as Tom had mentioned early, utilized extensive polling to gain consensus amongst the group. Like Tom had mentioned, there were a lot of members in there, a lot of subject matter experts, and a lot of opinions. And there's really no perfect system out there. We're trying to find the best system to allow us to get more accurate and more granular and more consistent data from the dull bits. So with that debate and that polling, we ultimately kind of ended up on that bottom category there, which is percent loss from an area perspective, as Tom had kind of alluded to earlier. And That we believe is going to provide better consistency. We know with automated machine vision systems that they will obviously be able to do that to a very high degree of accuracy. But even when it comes to a human or individual visually grading the system, the general consensus was that this would be a better approach to getting more accurate and consistent data. I think that's because we're kind of forcing the individual to look at it and try to quantify the amount of wear on each individual cutter based on 1% increments rather than on the old scale, which 0 to 8, you're trying to put it into buckets and estimate on 12.5% increments, which is just not that intuitive. So we believe this will lend itself to improved accuracy and consistency in the dual grade. But that being said, like we've been talking about, we do have field trials coming up, and the main goal of those field trials is to put some stuff out there, see what we obviously developed these theories on what we think will be an improvement, and we need to get some feedback on it. So that could change by the end state of the this project. Next, we'll transition into bit zones. So I'm going to get into subgroups a little bit more in a subsequent slide, but the majority of this work was done predominantly by one of our subgroups. And it, I think, is another really critical component to improving our understanding of drill bit damage and driving to that root cause failure analysis. We typically or historically, we're using a inner 2/3 to outer 1/3 system, which was very applicable to roller cones and makes sense, but was really not very applicable to a PDC bit and didn't do a good job of allowing us to understand what type of drilling dysfunction or loading would have caused damages in specific portions of the profile. So we're now transitioning to 4 sections, going from inner outer to now it will be cone, nose, shoulder, and gauge. The cone being that arc or that line there in the center, and then the nose being, if you were to place a clipboard or a flat object on the face of the bit, it would be the cutters on each blade that would touch that flat object. So really the best way to go about this would be to have that flat object on the top of the drill bit, identify your nose cutters, move further out, identify the gauge as the first cutter aligned with the top of the gauge pad, or it would run parallel effectively to the gauge pad. Once you've identified your gauge cutters and your nose, through process of elimination, it would be easy to identify the cone and shoulder. Another thing to note on the gauge cutters is obviously they're typically tip ground or gauge ground. So that's a good way of identifying those as you're evaluating the bit. But we believe this type of improved granularity into the drill bit zones will give additional color and feed that digital feedback loop to drive to root cause forensic analysis. All right, so on the additional considerations and subgroups, this, as we mentioned, we had an extensive subject matter that needed to be addressed within the bit group, and we decided it was really too much work for us to take on just with in the meeting. So we divided that up. We actually ended up with a total of 10 subgroups made up of 19 individuals. For the sake of time today, I'm not going to go through that list of names, but you know who you are, and we want to tell you we sincerely and greatly appreciate your participation. Without you all, we would not have made the progress that we have to date. The 42 pages worth of documentation that Tom mentioned earlier is in large part thanks to these subgroups. So thank you all for that, and we will continue to deploy that and splitting up this work. So just to hit on a few of these, we've already kind of gone over the drill bit zone definitions. Shaped cutter compatibility was obviously a big one. We know in the industry today and over the past 3 to 5 years, the utilization and deployment of shaped cutters has increased substantially. And so we have to make sure that the new system can adopt and can integrate wear severity and damage classifications for all varieties, which there are an extensive amount of varieties in regard to geometries being run out there today. So further to that, we also, while they're smaller portions of the bit business, and the impreg, hybrid, forehead, and roller cone, drill bit types were all considered, and we are working on documentation or have already drafted a lot of this to integrate that and ensure that even though they're a small portion, the new system will allow for improved methodology to capture quantified wear data, as well as classification of the different types of failures that you would see in each one of those. We also had a subgroup that was specifically focused on drill bit damage categories. And then the last one shown there is reason pulled, which is in collaboration with the BHA team, and Paul Neal will be talking about that in a subsequent slide deck. So to end, next steps. First thing first is, as Tom had mentioned, we have been working in the background on the 6 training set. We will be moving forward with field trials towards, I believe, the middle of this year. And to date, we have about 9 bits in there that we are set up to have run through testing and get everybody to try to grade these on a cutter by cutter basis, as Tom had showed earlier, using the damage categories and the wear severity measurement system that we previously discussed. After that, we'll take whatever feedback we get, revise, and then probably continue testing. We'll do some field testing. We'll do testing within shop type environments. So at the bid companies or BHA companies, and get that feedback, which will be critical for us to, we want to make sure that we've had every opportunity to gain feedback and to improve upon it before we finalize. After that, we will review the instructions, update as needed, and then we're going to be working extensively and have already started discussions with the data management team to develop the digital interface for the daily drilling reports. Obviously, with this new system, we're going to need a way to capture that data digitally, and that's where we're going to have a new interface there to ensure that all of the desired fields are in an appropriate format that works for everybody out there. From that, we'll move towards publishing the new standard. As you can see there to the right, we borrowed an image from Robert from his presentation there, and what that will look like as we move forward. So we're looking forward to that, and we appreciate all of the support and help from everybody thus far. We look forward to the continued work in this project. And so at that point, that's all we've got on the bit side, and we'll move it on over to Paul Neal with the BHA group. Thank you all very much.
Good morning, everyone. Thank you for joining us today. My name is Paul Neal, and I'll be presenting on behalf of the BHA group this morning. Our group is got quite a good spread of different, I guess, parts of the industry. We've got about 30 members assigned to the group. We have people from the service company side, from the manufacturing side, operator side, contractor side, and we're spread across about 7 different countries. So we've got a pretty good spread of people that's supporting this initiative. We're really excited to show you what we've got today and what we've been working on for the last 9 or 10 months. We believe that there's good work done. We believe the initiative is good, and it's going to be a tremendous help, not only as a diagnostic tool to evaluate the condition of the BHA after it's been run, but also as a tool to help understand what's happening downhole and to bring pieces of the puzzle on how we can drill more efficiently. So just briefly, today's agenda. First, we're going to talk about what the objective is that we're trying to accomplish with this initiative. We'll briefly discuss the charter, which is what we use to drive direction when conducting our meetings. From there, I'll discuss the work group structure, which will give you an oversight on how we divided up the BHA, and then subsequently the teams that were built to create those codes. From there, we'll go into detail on the coding structure itself, and that will give you some insight on how we're going to grade and what the grading system is going to look like. And then we'll go into the items that we have left to work through. And finally, we'll be presenting 3 polling questions. Those questions are going to be just quick yes, no, multi-choice type questions, and I ask that you respond just to help give us some feedback for both our group and the group. So that'll be a huge help to us towards the end of the presentation. So our objective is essentially to establish a set of coding standards to support the workflow that will contribute to a better way of doing and diagnosing drilling mechanics. The focus of the system will be to break out the BHA into different components, motors, MLWD equipment, rotary steerable tools, performance enhancement tools, and then stubs, stabs, and collars. The bit dull grading system has been around for decades, and it's been adopted globally and has served us very well in creating a picture of the condition of the bit once it's above rotary and it has been run. And it's been a critical tool in improving drilling performance. But there's nothing been done on the BHA side, right? Tom and Dustin talked earlier about how they're going to be improving on the bid system. But we felt that it was important for us to create a system that formally captures this from a BHA perspective. So our goal is to essentially create that system and implement it and drive it forward. So our charter statement, basically this is kind of an overview of our charter statement. And we use this to guide us and direct us through our processes and conversations, right? And there's four main pieces that I want to kind of highlight today with you all. So first and foremost, we want to create a forensics tool and a best practices document that we can use for BHA code. This will show how the tool is to be used, how the coding will work, and define the boundaries within the system. And this will be published within IADC and SPE. So next, we want to review and propose any codes that can be used to describe the condition of the BHA and help diagnose downhole tool conditions and events that will happen when the tool is below rotary table. The intent here is not only to look at codes that can be attributed to BHA, but also codes that can be used for the reasons pool category, as Dustin mentioned earlier, right? So we want to use existing codes. We want to create new ones that will actually paint the right picture moving forward. We're looking to develop an archive of case studies, photo examples that can be used for training purposes and as guidance when doing the BHA dull grading. And then finally, we want to be able to develop and execute a field test plan, right? So the intent is to field test the coding system and then to adjust any issues or shortcomings that was identified during the field testing process in order to make it as field ready and user friendly as possible. So basically at the highest level, we want to create an effective BHA system, coding system, develop the support that's needed, field test it, and then roll it. So the work group structure basically is what we're using to break up the BHA codes, right? We quickly realized that one coding system wouldn't be very effective in coding all BHA components, and it'd be too cumbersome and difficult to use. So we decided to break the BHA up into different subgroups. We felt that this would allow us to develop codes more specific to the product and would allow the user to break up their evaluation a little more efficiently. So of the 5 groups, the first group was the motors group. And basically the way their systems broke up is they broke up the motor into different assemblies, which you'll see later in the presentation. And this will allow the user to code different parts of the motor, such as the power section, transmission, bearing assembly, and so on. Next is the rotary steerable group, and basically they've developed codes not only to give a picture of the condition of the tool, but also codes related to steering functionality and data transmission. The data acquisition group, so this group focuses not only on MLWD equipment, but also equipment that's tied to capturing drilling mechanics data. Their coding system will allow for observations related to condition of the tool, but also associated with sending and receiving data. The performance enhancement will cover technologies such as vibration mitigation, friction reduction, jars, and so on. So they've got quite a broad range of technologies that they're covering. And then finally, it's the iron group. So these are codes related to stabilizers, collars, subs, and so on. And they'll be focusing on condition of the body of the tool, but also the condition of the stabs, the stabilizer blades, and the connections between them. So each team, in essence, will develop their coding system, and it would be specific to their technology, but the intent would be, as a whole, there'd be a similar look and feel across all the different groups. So for example, the codes that are used in the iron group would also carry over to the other groups with respect to any coding that's associated with, the body or the connections, right? Similar to that, codes that are used in the data acquisition group would also carry over to the rotary steerable group with anything that has to do with data transmission and so on. So that's essentially how we broke up the different parts of the BHA. And the next few slides will go through the structure, we'll say. We broke up the project into two phases. So phase one is the one we're primarily focusing on right now, and phase two is more of a future phase that will be implemented once phase one is kind of underway. From a coding perspective, we've divided up into 3 levels. So the intent now is to give the user different level details on the condition of the BHA, right? So level 1 is a high level code, right? It's fairly basic. It's essentially, it would be part of the run report, and it will quickly flag any issues with a part of the BHA that requires some review and investigation. So basically, once the tool once the BHA comes above rotary, it's to look at it to say, oh yeah, there's something that doesn't look right here. We need to look into it more, or something that doesn't look normal, and we need to flag it for investigation. So it's a quick look. The level 2, it's more of an in-depth look, right? So the intent here is to observe and document the condition of the tool and to help diagnose borehole conditions or the drilling environment, right? So this is where the different groups come into play. So each BHA component will have a separate level 2 coding structure, as we previously talked about. And in this essence, it would be the coding exercise done for motor and then a separate one done for the MWD, and so on and so forth. And these are the 2 levels that we're working through right now. The level 3 coding system is basically an attempt to standardize classifications when doing root cause analysis and reporting on post-run investigations. That's something we'll. So if you look at the level 1, essentially to the left is an example of a run report, right? But to the right in green, you can kind of see the mock-up of a level 1 report. And that level 1 report would basically be embedded inside of the run report, the drilling report. So on the left there, you see the different parts of the BHA, right? So bid, MWD, PDM, blah, blah, blah. And then just to the right of that, you'll see some preliminary information, right? So you see, serial number, OD length, and so on and so forth. And then right below that, there's additional information for drill pipe, and reasons pulled and BHA performance and information that you can also be added to that portion of the report. But basically right now we're just kind of focusing on the top. So next to the BHA components is the level 1 grading system. And again, it's a quick look, right, for if there's any issues. So we use a designation as okay to show that there's no major issue with the tool, right? RI designates requires investigation, and then N basically is a note to say that this element wasn't run in the BHA. So we have 6 different main codes that we use to detail the primary area of concern. So they would be, back off, washout, cracks, bell connections, fracture, or other. And then we have 8 codes to reference where the damage located, right? So power section, kick pad, bearing, stab, a connection, manual, body of the tool, or other. So for this example, if you look, the bit and the MWD checked out, we had potentially a back off with the motor next to the power section. So basically across PDM, you would say RI and then BO for back off, and the location would be power section. And then everything else checked okay. In this particular BHA, there was no performance enhancement tools run or anything from a stabilizer perspective. So now we're going from the level 1 to the level 2, right? So the level 1 was the high level. The level 2 is basically now the coding system that you would use to code the motor itself. And what the motor code would look like is different than from the MWD. It looks slightly different from the rotary steerable, but this is basically a picture of the motor. So for the motor coding, we've broken the motor down into 8 different sections, right? So we have coding for the top sub, the power section, transmission, bearing housing, stab body, kick pad, bit box, and then the stabilizer blade. And within each section, there's 3 different pieces of information that can be added. So for each section, there's the FD, which is the, I guess, the failure or the damage code. L is for location, so where the damage is, and then WS is what we call the wear severity, right? So for the damage code, it can be, back off, washout, crack, bell connections, fracture, wear, location, upper, middle, lower body, and then wear severity is low. So, you would go through your tool and then you just plug in the codes as needed, right? And then to the right, there's a section in there that does field observation. So basically, it's an additional section where you can add more information. For example, you can add things like, issues with the power section draining, free rotating or locked up bit box, stalling, issues with directional control, power loss chunking, or issues with the bearing play. And oftentimes we see these sorts of comments embedded into the body or into the comment section of the drilling report, and we're just looking at ways to kind of formalize and capture this information. So if you look at our previous example, we basically we're looking at the back off incident, right? So we would go in and when the tool came above rotary, there looked to be a back off. So the user would then go into the power section portion of the code, and they would enter BO for back off. And then for the location, it was the lower connection. So they would just enter L as a lower connection, and then WS would be a 3. Right? And then subsequently, then going through the BHA or the rest of the motor, they noticed maybe there was a crack in the body of the kick pad. So they would go in and they would say that there was C for a crack, location would be B for body, and wear severity would be a 3. So if there's anything that was noticed as part of the motor, they would just input that into the code. And then, during the run, there was some power loss and some stalling. So they would put in PL for power loss and SG for stalling. So once the motor was done, then they would go on to the MWD, fill out something that looks similar to this, and then so on and so forth for the rest of the DHA. So the reasons pooled is another initiative that we're working in conjunction with the BIT team. And while we were reviewing the codes, we felt that there was a need to update these as well, right? So the majority of the codes here are suitable, but we wanted to add a little more granularity to the system and remove anything that was considered presumptuous. Right? So we added several codes to give a little more detail. For example, we included things like battery consumption or data communication with MLWD or rotary steerable tools. And we also segregated things like, tool face control as part of the reasons pool, right? So we wanted to give a little more specificity to the BHA, why it was pulled, and remove anything that needed further description in the comment section. So we're again trying to formalize how things were laid out. So to recap, essentially we've created 5 different groups we felt that could be bundled together from a coding perspective. We created the codes within each of these groups, and the intent is to individualize the structure to give it to give each portion of the BHA some or a better level of detail when it came to doing the codes. We're focusing on the level 1 that's used to flag, and then the level 2 that's a little more for detail. We've also added 13 new reason pool categories, and today we've established about 50 codes so far. I think once we start the field testing process, that's going to change slightly, but we'll see how things go once we start field testing. And with respect to what we have left to do, we've done a lot of work so far, but we have quite a bit left. We've got to finalize the field codes for the remaining groups. We want to make sure that we capture as much as we can before we hit the field test. Continue to collect examples for the case studies group. There's still quite a bit of work left to do here before we start testing. I think once we start field testing, we'll collect more and more examples. Working with the digital team, we want to make sure that the digital interface has been established, and there's a proper structure for archiving the data. We want to make sure that we can retrieve the data when needed, and that data brings value. Working with the build team, or sorry, the bid team, to make sure that we've got a cohesive coding system. We want to make sure that reasons pulled portion of the code is compatible with both the BHA and the bid group. Establish a field test plan. Look for how we're going to do it, where we're going to do it, volunteers to do it. Establish benchmarks and what defines success for field testing. And then finally, to complete the documentation and to launch. So with that, real quick, Linda, if you could you put up the first polling question? So the first question, do you think that a standardized BHA dull grading system would be supported with your respective organization? And again, it's just a yes or no. If you could just do a quick vote there now, that would be great. And I'll give 30 seconds to do that. Okay, can you post the next question? Yeah, okay, so who should be the owner of the person to execute the field-based BHA dull grading process to provide an unbiased evaluation? So should it be the drilling supervisor, the contractor, or the service provider? I'll give another 30 seconds for that. Okay, and then the final question. Would you like your company to be included in the testing, the proposed dull grading process? And again, that's a yes or no. Perfect. So for those that had responded yes, if you don't mind, in the chat box, if you could just give the name of the company you're with, and then when it comes time to start working through the field testing process, if you're so inclined, we'd love your help. We'll reach out to you to get that portion of the program moving forward.
Good day all. I'm Willie Watson, and it's 8:05. Let's get kicked off with the case studies and the case studies group. So what I'd like to do today is talk through the case studies group, what we've been doing, where we fit in, and where we're going to be going there too as well. If I was to look to summarize, what's the objectives of the group? Well, our objective is to focus on creating case studies where we look at the common modes of dysfunction. and looking at that common modes of dysfunction, link that to the post-run forensic evidence. The purpose is for training material and really to link the codes that we're generating towards that to help with the continuous improvement investigations. The outcomes we're delivering are the forensic evaluation workflows and also providing continuous improvement best practices. This will come through SPE technical papers and also the IDC guidelines. So where do we fit in? We've heard already today through the drill bit team and the damage areas they're looking at from the BHA team and how that comes together. We will soon be hearing about the data collection team, surveillance. What's the elements that can be linked together? And something we start to see when we start to investigate some of the damage causes, we start seeing that a lot of the damage causes can be caused by specific types of drilling dysfunction. If we have an ability to try and pull this together by combining the damage, the forensic evaluation with the damage, with the actual conditions that we've seen that the drill bit and the BHAs have been exposed to, that can help us diagnose the failure. And with that, we can implement real-time changes that the driller can take part in straight away to try and change that environment. And certainly as we go forward and look at the system, take a systems approach, look to go through and redesign the system. So in essence, where we come in from the case studies is really focusing on that diagnostic part, linking the damage to the information that we have. And as we came together through last year, we started to reach out to the community, to a group of different individuals that's been looking at drilling forensics and drilling dysfunction across there. And we put a number of polls out. We identified what's the main forms of damage that you guys are seeing to date across the industry worldwide. And these were some of those that were coming back for the bit damage and the BHA damage. If we look real high level, what we tend to see is a lot of the damage, in particular the BHA, the top three, it's related to whirl, lateral vibration. We see a lot of torsional vibration coming through here as well, whether it's HFTO or stick slip down through the bits. And equally a number of other areas too, transitioning through hard transitions, coming on with tangential overloads and the likes. So our purpose has really been to explore some of these areas, map them through, identify and create training material that can help the codes as we go forward. And very early on, we start to ask ourselves, what does a good case study consist of? Within the industry, we can see some salesman elements coming in where if we use this type of additive or use this type of cutters, we can drill faster. Well, we've been looking to try and explore a bit further. Why has the damage occurred? What were the conditions that caused the damage? And effectively framing that in a way that can be passed on to engineers so they can understand, take the conditions and take the understanding and use that to help them improve their future performance there too. So the process that we've adopted as we come through the case study group, we've been meeting regularly through the course of last year. We would identify a case study, or if someone's got a point of interest, some photos, some observations they've had on the rig, pulling that together into a form of presentation, making sure you've got the internal approvals, deliver that throughout, and then taking the feedback back from the SME forum. And as we heard earlier on from the BIT community, there's some of the areas that we're seeing we can quickly reach consensus. There's also areas that we're touching on where we start seeing we're really at the bounds of the industry or the industry knowledge. And in this case, it's good. It can help us identify where that bounds are and potentially offer some different thoughts in there as well. From that, we come through and we're uploading, creating a database of this data, the publications, the presentations, and the material, should people want to investigate them further for themselves. And start to come through with that, with a number of SPE papers starting to come through, and taking some of the best of these into what we'll consider a best practice document in the future. Through our efforts in 2021, we delivered in total 18 different case studies, investigations, where we conducted drilling forensics on these different failure types. We also have 2 publications that are preparing to be released at IADC conference in Galveston, and a number of presentations we gave there as well. let me talk a little bit more, maybe just give a little insight to some of these presentations and some of these publications that are due to come out in March. A little teaser, if you may. So when we start to explore with our forum, our subject matter experts, we put out a poll. People were given their time to come in to look to the case studies, and we said, well, you've got some special skills. You've came here from drilling contractors, from drilling operators, from universities, from some bit specialists, a lot of background there and a lot of different expertise. What's limited you use your special skills? And it's quite interesting seeing that come back. There was a consensus around about data and having the availability of data and the ability to process and filter data suitably. Second is time. Now that time element can equally be interpreted. How do you take the process? How do we work through drilling forensics in a methodical way such that we can collapse that time? And equally the training. It was quite common. People would see that they would go down, and as you come into drilling forensics, it's very easy to go down into rabbit holes, and drilling forensics can be a rabbit's warren through there. So we set out to try and target these, trying to create that link between analytics, engineering, and operations. But what was interesting, as we start to see, we saw on the data front, we were dealing with common problems. Frequently, when we'd come in to start investigating a failure or start to look at different elements from forensics, it can be quite common where, for a start, we would be asking them, like, a little bit more information. And it doesn't take long before we're all dealing with information overload and swamped with data. But a key that we start to see as we start to walk through that case studies, walk through a number of them, there was often a smoking gun. And that's where we've been trying to establish and develop a process, how we can find that common balance between confusion and information, getting the right amount of information such that we can go ahead and take some decisions, diagnose, and move forward. So with that, that's what we've set out to do, specifically with one of the papers, the first paper that will be presented at the IADC conference. We've mapped out for the industry potential data sources that can be considered and where they can be obtained from. Equally with that, in that we've provided a framework, a structure in how this data sources can be collated, how it can be compiled, sorted, and effectively processed through, so you can start developing some meaningful information that can establish and provide insights into what's drill bit forensics. The second paper we've put together really is round about photo documentation. We've seen this picture. A picture may tell 1,000 words. Some pictures may tell more words than others. Unfortunately, that doesn't work in reverse. If we look at the IDC code, it's an alphanumerical code, and trying to get that or trying to convey with a limited set of words and numbers, the condition does have its limits. What we acknowledge and see that within industry, there's a lot taking place with regards to image processing, photo documentation and image processing. Advanced analytics are really looking at this from an AI perspective and will open a lot of new doors. But what we acknowledge is that if there's a standard process in how we recommend photographs to be taken from at the rig site, this can certainly help with drill bit forensics also and provide that baseline. This we're offering to the industry. It's been pulled together by some of the best practices that a number of operators, leading operators, have in place at present. And from this, they've seen step changes in the rig sites that are using and adopting these. We'd like to see this come through as well. We've offered this in throughout. We would like to see it trialed and effectively refined as we come through. And this is something simple that can be deployed in effectively every rig site that has access to a digital camera with it throughout. So taking a high level overview at the project, if we look at the tasks that we'd set out for the case studies, the drilling forensics team, and where we see that in relation to some of the other elements, the other project teams that are coming together on this effort, we've seen that we've looked far, we've diverged out, we've looked at a number of different case studies and identified that common modes of failure. We're now starting to converge into our solutions and move forward. And we will see that as the codes are coming through and refined. And in the near future, we will soon be in a position to go through and deliver a pilot on these codes. With those coming through, we'll look to yourselves, to the industry, to provide feedback with that. And what we'd love to do is have the ability to see, for example, the photo documentation. If you can talk us through that, if you can follow that as we've presented it out, present back pictures, we'll learn from that and refine that and use that to help us refine the codes and the processes as we go forward. So what do we have stored in 2022? We kicked off last week. Paul Pastusik took us through a great example with regards to whirl damage with our throughout. And on the 2nd of March, we've got Fred Dupree lined up there as well, also taking us through and looking at different cuttings and how the cutting the different rock types can impact the potential damage and returns we may see out there too as well, with Rafat closely following, coming on the 16th. We've lined up also in the early works of a 3rd paper, and that really will be focusing on surface and downhole data, the information that you will have at the rig site, how you can interpret that, so some of the tricks of the trade, and how you can take that through and help support drilling bit forensics. And as we start looking beyond that, we see that with time, we will naturally come through a transition and come to a product with the revision to the IDC code. The case studies it's been great, it's been energetic, but it's really opened up and provided the bedrock for what we may consider as drilling forensics. And with drilling forensics, we're starting to look at that. There may be some opportunities where we can consider that in the industry and look at taking that and making it evergreen. If some of this is of interest to you, or some maybe of interest to someone in your company, what I would suggest with this, drilling forensics, where to start, do a quick search on this, Google search. We had last year, Paul took us through and gave us an overview with drill bit forensics and gives a great introduction to some of the common modes with it throughout. Tune in to the IDC conference on the 10th of March. Prepare for that, and we'll have that publications, and those will be talked through and presented throughout. And equally, please get in touch with the IDC team. We're keen, active, and very interested. If you have case studies, if you've got something interesting or something that you're not too sure about and you would like some SME input, please bring it forward. We would love to hear from you with that. And with that, I would like to hand you over now to David on the data management. Thank you.
Good morning, good day, everybody. Thanks for that, Willie. A lot of progress has been made here. So I'm David Shackleton, and presenting on behalf of the Data Management Work Group. We're about 35 industry experts from academia, large service companies, bit manufacturers, data collection, management and reporting and analytics companies, large operators, and of course the drilling contractors themselves. Where we see ourselves, it's like Dilbert providing information, great quality information, of course, to senior management. But times have changed a little bit since the late 80s when Dilbert first arrived on the scene. More and more people are involved with the data collection process, data management process, exchanging data, and essentially getting a hold of data, process data, so that they can use it to help them make good decisions. So we see more people wanting access to the data and creating the data itself. Just what I'm going to talk about here, I've talked very briefly about the team, which has been very supportive, incredibly knowledgeable, and we'll look at what our original objectives were and review those and look at the charter statement. We'll look briefly at the series of presentations that we've looked at last year. We'll look at the kind of on-paper distillation of that, the guidelines documentation, talk about the training data set, and next steps for this year. So like the other teams, we were looking at redesigning the grading system, focusing more on root cause analysis rather than just the reason for pulling the bit. We've been requested to put these down on paper in a series of guidelines, which we've had a go at. And also there's talk of the data set, the training data set, which we'll get into a bit later. So firstly, we started looking at best practice, what is currently done, what standards exist already, what are other companies, other people doing in the industry, and what works the best, which flows of data, stores of data, work the best. We look at different ways of digitalizing the visualizations in terms of photos, videos, 3D models, and so on. So here's a kind of series of masterclasses that we enjoyed last year. From data management companies, specialists in taking the images of bits, the big operators, and large service companies. And you'll see things kind of came to an end there in the fall. And we spent the last kind of quarter of the year putting together the best practices documentation, trying to get this down on paper to share with the wider industry. So let's just have a look at that. I mean, why are we doing this? We're focusing on the bit and the BHA, but also a lot of the surrounding data, data about that data, metadata, and the wider operational data that is connected to the performance of the bit and the BHA. Why? But for reporting, for reviewing forensics, and optimizing the entire operation. So the first part of the document looks at what is currently working very well, what's established, what are the standards being used, and operability between those standards or using those standards. So firstly, we look at data storage and how that data is accessed, data structures, data model types, standards, existing standards like the well-established PPDM, WITSML, data models, and data exchange protocols. The DDR Plus, developed a couple of years ago as a standard for passing on the operational data for the day. OPCUA is still used broadly. Then we looked at more modern ways of exchanging data like JSON and RESTful API, lighter, faster ways of exchanging data. We looked briefly at the OSDU from the Open Group, and DWIS, focusing on the interoperability of different systems. 2.3 here, we looked at existing standards in sharing data. For example, the incident statistics program that's been going for decades successfully with the IADC. Between operators, the Rushmore reviews, now part of IHS. So the next chapter looks at more cutting edge or more examples of good practice that perhaps not all companies are using, or not most companies. Again, more on data storage and the detail of the data. And you'll see at the end, in terms of detail, we've got quite a lot of detail in the appendix defining different parts of data models and so on. How is this data validated and verified? Data about the data, metadata, governance generally, how are companies putting on paper how they manage data, the different systems they use, data quality, data security, data access, and importantly, data automation, process, collecting the data, analyzing the data, exchanging the data. A lot of work has been done recently on automating that, and more has to be done there. And then more on their data exchange, the OSDU as a developing standard protocol schema for sharing data and capturing and storing data. And then the next chapter, we try to look into transition. How have companies gone from one system to the next, the next, you know, from radio calls to faxes to emails to database systems, web-based database systems, and so on and so on. How have companies moved between these different systems? How have these changes come about? And how have companies done these? Again, it's still about interoperability, how these systems work together. Still work to be done here. And again, automation, there's still work to be done. Machine learning, we want machines to have access to this data so they can help us learn from the data and make good decisions about the data. Smart contracts, using the data to analyze it and feed into automated contract systems that eventually will lead to payment. That's something several companies are looking at. and data quality management. So the last part of the charter statement was to develop this training data set that can be searchable, secure, accessible, and so on and so on. And it's clear that systems like Dropbox, even commercial systems that are used within companies, if you've ever tried using them to collaborate between companies, half the people can't get access. It's very difficult, and you often end up reverting back to emails, and versioning control becomes impossible, and it's more complicated than that. A more solid system needs to be developed. So this group, the data management group, has looked at what the other work groups are putting together and come up with perhaps not specifications for this training set, but at least some considerations that we need to bear in mind. So this is the next chapter, chapter 5 in the guidelines document. What would this training data set look like in terms of structure? How would you give permission to access this data? Different roles of different people from different companies, perhaps. How would this data training set be integrated with other systems like email or other databases potentially? There needs to be some kind of arbitration if some people think there's some data in there maybe should not be in there, or perhaps they put some data in there that they later decide didn't want to be in there. What's the process of perhaps removing it or doing something else with it? Data ownership, who owns the data that is in that training set database, or perhaps rather than who owns it, who can do what with it? Data access, how can it be accessed securely? How can that access be controlled securely? And so on and so on. Considerations to take into account here. And then at the end, we acknowledge the work of the different authors and contributors to the group, not just in terms of putting together the documentation, but in terms of providing input at the meetings and doing presentations and so on. And at the end, there's quite a large appendix of terms and definitions, which can be pretty useful for learning from or referencing, and then a list of abbreviations that we've used at the end. So what do we still have to do this year? Well, we're going to work with we're going to continue working with the other groups, the BHA groups specifically, particularly, about whether their conclusions fit with existing standards like PPDM or WITSML, and or whether these need extending or something else. And with the case studies group, do existing data management best practices facilitate these case studies, or do we need something new? And then, finally, so we've put together these, not specifications, but at least considerations for a training data set. What we probably need to do now is work with the leadership team and the other teams and with the industry to design a roadmap for making this into a reality. So that's it from the data management work group. Thank you very much. And just finish with this slide. So if you're interested in joining the data management team, if you see something missing or see some ways that you can contribute, please do get in touch. Or more generally about the whole project, please get in touch with the leadership team, and you have that specific email address as well. Hopefully that's gone into the chat somewhere for you. So I'll leave it there and hand back to the leadership team. Thank you.
Thank you, David. First off, David, Willie, Paul, everyone, Dustin, I just want to say thank you for everyone that's presented so far this morning. I hope that if you're part of the attendees group here, that you've got what you want from this in terms of an idea of where we're going and what we're doing. We try to be as open as possible. Linda is recording this session, so if you want to share this with others and let them know, then just contact the IDC or look on the ID site for this recording of this session. As Willie said, we've got 3 papers being presented at the SPE IDC conference coming up in March. We have more papers planned for the future as well, and of course the IDC documentation, the official documentation for how to go about documenting this will come out at the end of this year. So with that, I will open it up to additional questions. I've got in your Q&A box, I've got the number of people that have volunteered. We've got about 10 volunteers that have said they would like to test the system when we're ready. And of course, we've got everyone that's on these sub teams are planning to get their organizations involved as well. I'm just reading here. I see one note from Hani Ibrahim, which is there's a company called XAIT. Collaboration tool for exchange of pictures and reports. David, if you haven't talked to Hani, or Hani, if you haven't talked to David, then please get together and let's make sure that they're invited in that group to look and see, if you will. So, oh, there we go. All right, so. With that, there was a couple other questions. Robert Estes asked how many people were online. Right now, we've got 11 panelists and 45 attendees here. Any other questions from anyone about the system or where we're going, kind of the feedback? We tried to be as open and as inclusive as possible. I hope that this one lasts as long as the last one. I'm absolutely amazed when I look back at how long the IDC code system has been in place. And you know, when it was put in place, we had these things called digital cameras, and they would take like 512 pixel images or something like that. It was horrible. You know, I mean, I can remember waiting a couple of months for photos, for hard copy photos to come around the world to look at those, and the feedback was months basically to between the time that you took pictures, you ran a bit, and you got the feedback, and you gave feedback back to a drill team somewhere in the world. And today, I can't tell you how many times that I get a phone call that says, we're out of the ground, this is what we have on site, look at these pictures, we're fixing to go back in, do you have any additional advice? And hopefully that's more exception than reality, but it happens. I mean, and it's good to be able to do that when someone asks for help. Within Exxon, we try to train everyone to be standalone, independent, and make their own decisions on the rig site. But everyone, trust me, everyone likes to have someone else to bounce ideas off of and verify that they're correct. So, any other questions? Anything else that I'm missing? Let's see, Q&A. Information upcoming technologies, sensors like in-bit sensors, particularly Cerebro was mentioned, but certainly there's a lot of work with downhole recording devices, whether it be like the Cerebro or Black Box, or somebody remind me of Baker Hughes' system that I'm drawing a blank on right now, that used to be called Databit. Now it's a Multisense. Thank you, Dustin. So anyway, that we use a lot of those in-bit sensors, high resolution. One of the nice things about them is you're getting vibration and now weight and torque data at the bit below the motor. You can see what your weight transfer is. It helps tremendously on diagnostics and is a part of that data stream. So absolutely. There are some case studies, by the way, that is in Willie's group. We've got some case studies that are planned that include those how to use that downhole data, not just the surface data, obviously, because what I like to say is that the drill bit itself will tell you a lot about what happened. Downhole data will tell you even more. The one thing the surface data can usually tell you a lot is about when it happened. So you see a change in ROP or a change in pressure or something that happens at, you know, at the end of stand X, whatever that may be. You can tell exactly when it happened. What you may not know is exactly what happened until you pull everything out of the ground. So between the two of them, it becomes a pretty good case for forensics. So panel, I thank you very much. This has been a truly world-class effort. We've got not just the people that you see on this panel, but there's at least 150 people that have been involved in this effort so far, and it suggests that there's a lot of interest in improving the way we work and improving our feedback mechanism. So I consider this just as important as any other feedback data, or, you know, people talk about big data sets and all the time. And we're pretty good about messing around with digital data, but when it comes to images and photographs and forensics, it's been a lot harder, right? So we need to make sure that we're using all the available data sources. So Robert, you kicked us off. Any closing remarks?
Well, the closing remarks I have is please come to the conference where the papers are presented and actually meet live the people that are behind it. And I would say keep track of our activities. Like Paul said, we're very open in what we do, and we need as much industry input as we can get, especially during the trials. The hard work, well, part of the hard work is done, but now consolidating the 4 pillars or the 4 buckets into one document is probably going to take place in the coming months, and we're not sugarcoating it. That will be an interesting process, especially because we're still working all virtually from homes and all that, but we're pretty certain that we can get through because of the quality of the underlying work. And I would say keep tuned. Paul, are there any ideas of another outreach somewhere in August or the end of the year?
I haven't, certainly we haven't scheduled one yet, but I would say we'll need one, something toward the end of the summer. Would be August to September. We may let people get back on station if they're off vacations and such. Go for something right at the end of the summer, I would think would be a good time to do that. And then we do have a paper proposed for the SPE October conference that is a paper with Willie and crew that'll be a follow-up of some of this work as well. But I think that everything we're doing in the IDC code group, as far as the actual documents, will live with IDC. We may not have everything in time to present at the annual technical conference, that kind of final document, but we'll certainly be able to mention it as well. So anyway, that said, thank you all very much. I really appreciate it. And Robert, you said something really good about not sugarcoating it. I was looking at Tom Roberts and Dustin's work group when they set up different cutter examples and had their work group vote on what happened. And oh my goodness, the subject matter experts were violently discussing what were the root causes and such. So I thought that was great. It just tells you that you know, that subjectivity of humans, that's what we have to deal with, and we want to reduce that as much as possible and use your expertise, the people that are on this call, to help us. So all right, with that, thank you all.